Good morning, students. Today we are going to see about checkpointing and rollback recovery in Unit 4. So already we have discussed about the introduction of checkpointing and what are the types of checkpointing, what do you mean by local state, what do you mean by consistent state, failure recovery. So these are the topics already we have covered. So today we are going to see about coordinated checkpointing and uncoordinated checkpointing. So what is initially how we classify the rollback recovery scheme means we have two types of rollback recovery schemes. One is checkpoint based, the other one is log based. Under checkpoint based we have three types: uncoordinated, coordinated and communication induced. And under log based we have three types: pessimistic, optimistic and casual logging. So what is uncoordinated checkpointing? Already I told you. Each process takes the checkpoints independently. The process no need to interact with the other process before taking the checkpoint. That's called uncoordinated checkpointing. So what is coordinated checkpointing means the process should coordinate with other processes before taking the checkpoint. What is communication induced checkpointing means each process takes checkpoints based on the information which is attached on the application messages it receives from the other process. For example, if process PI receives the message from PJ, in PJ's message we have some information regarding taking the checkpoints. So based on that message you have to take the checkpoint. Based on the other processes messages we have to take the checkpoints. It's called communication induced checkpointing. So what is uncoordinated checkpointing? So each process can take the checkpoint autonomically. That is, individually they can take the checkpoint. So the advantage of uncoordinated checkpointing is the runtime overhead is low. Whereas we have so many disadvantages. The main thing is domino effect. And the other one is recovery from a failure is a slow process because the processes need to iterate to find out a consistent set of checkpoint. So we have so many checkpoints. So you have to iterate through all these checkpoints to find out a consistent checkpoint. That is a very slow process. And one more thing is each process should maintain multiple checkpoints, and to remove the unwanted checkpoint periodically they have to invoke a garbage collection algorithm. And this uncoordinated checkpointing is not suitable if the application needs to write so many outputs. All the processes records the dependencies among their checkpoints during the failure-free operation. For example, direct dependency tracking technique. So we have two processes, PI and PJ. We are assuming that each process PI starts its execution with an initial checkpoint CI0 and PJ starts its execution with the starting checkpoint CJ0. And during the regular interval we are taking the checkpoints. So for example, IX and IJY, they are the checkpoint intervals between two successive checkpoints. The time duration is called the interval between the checkpoints. So if the process PJ receives the message from PI, we have the dependency between the interval IX to IJY. So it is recorded in storage. These two intervals are dependent. This is called direct dependency tracking technique. This dependency is later saved onto the stable storage when PJ takes the checkpoint CJY. That's about uncoordinated checkpointing. The next one is coordinated checkpointing. Under that we have two types, blocking checkpoint and non-blocking checkpoint. So what is blocking checkpoint? The name itself implies after a process takes the local checkpoint, it should remain, the process should be blocked until all the processes takes its checkpoints. That is, the entire checkpoint activity is complete. What is the advantage of this blocking checkpointing means? It's used to prevent the orphan messages. But what's the drawback means? The computation, the entire computation is blocked during the checkpointing process. The other type is non-blocking checkpointing. So the reverse of blocking checkpointing, the processes need not stop their execution when taking their checkpoints. So these are the two types of coordinated checkpointing. The main problem with coordinated checkpointing is we have to make sure the processes should not lead to any checkpoint inconsistency. So checkpoint inconsistency is the major problem in coordinated checkpointing. So what is a checkpoint inconsistency? So for example, we have the message M which is sent by the process P0 after receiving a checkpoint request from the checkpoint coordinator. Assume M reaches the other process P1 before the checkpoint request. So now the sending is recorded in P0, whereas the receiving, we are sending the message. So see the diagram. The initiator is initiating the checkpoint request. Okay, after receiving the checkpoint request by P0, it sends the message M. So the sending is not recorded in P0's checkpoint, whereas that same checkpoint request is received by the other process P1. Here the receiving of the message M is recorded. So this is called orphan message. Receiving is recorded, but we have no proof for sending. So this is called checkpoint inconsistency. So to overcome this, we go with FIFO channel. So that is, once the initiator sends the checkpoint request, it is immediately sent to the process P0 and P1. After that, they have taken their checkpoints. When taking the checkpoint, it won't send any other messages. After the checkpoint process gets completed, it sends the message M. So each message is transferred by using the principle FIFO. So which message is initiated first? Checkpoint request message is initiated first. So it is delivered first to the process P0 and P1. Then only we are transferring the message M. So thus it avoids checkpoint inconsistency. So we move on to the third type, communication induced checkpoint. So again here also we have two types, autonomous checkpoint and forced checkpoint. So hope you remember what is communication induced checkpointing. Okay, along with the application messages, you need to piggyback the checkpointing information. That is, you have to attach the checkpointing information. So what is forced checkpoint? Each process has taken the checkpoint forcibly by the other messages, whereas autonomous checkpoint automatically, without any constraint, without any forcing, it takes the checkpoint. So this is called autonomous and forced checkpoint. So the drawback, the advantage of communication induced checkpoint with the coordinator checkpoint is here you don't need to send any special coordination messages. In communication induced checkpointing, we have two more types: model based checkpointing and index based checkpointing. So what is model based checkpointing? So here you have to build a model. Okay, so this model is used to detect the possibility of the patterns that leads to checkpoint inconsistency. Okay, that is, you have to prevent the patterns of communication and checkpoints that could result in inconsistent state. So for example, if we go like this, it leads to inconsistent state. So these are the assumptions. So we have to build the model based on this, based on some heuristic, based on some rules. We are building the model. So this model is used to detect the patterns which leads to checkpoint inconsistency. So by using the model, you can prevent checkpoint inconsistency. The next one is indexed based communication induced checkpointing. So here we follow the index principles. So this index value is monotonically increased. Whenever we take the checkpoint, this index number is automatically incremented. So the checkpoints having the same index at different process form a consistent state. For example, if P0 is taking the first checkpoint, it is noted as PI1. So the same index is used by the other process Pj also. So when Pj takes the checkpoint, it is denoted that checkpoint as Pj1. So the indexes are same. So they form a consistent state. Whenever the checkpoint is recorded by the processes, you have to increment the index value automatically. So these indexes are attached with the application messages, and using these messages, the receiver decides whether they need to take a checkpoint or not. So that's about communication induced checkpointing. So once again, so for all, we have studied about checkpoint based rollback recovery schemes. Under that, we have studied uncoordinated checkpointing. Uncoordinated means we don't need any coordination among the processes while taking the checkpoint. Here we use the technique direct dependency tracking, and this is one example. The second type is coordinated checkpointing. So here the processes should coordinate with one another before taking the checkpoint. So here we have two types, blocking and non-blocking. And here we face the problem checkpoint inconsistency, and we have studied how we resolve the problem using FIFO channel. And the third type is communication induced checkpointing. So here we have two types, model based checkpointing and indexed based checkpointing. So we have categorized the checkpoints as two types, autonomous and forced one. So in communication induced is an example for forced checkpoints. So in the first model, in the first type, the model is developed to detect the patterns which is used to find out the checkpoint inconsistency. And the second model is indexed based communication induced checkpointing. So here the same index at different processes forms a consistent state. Whenever we take a checkpoint, whenever we need to conclude a consistent checkpoint, we have to follow the index value. So we have to take the same index value in every process to form a consistent state. So the index value is automatically incremented whenever the process takes the checkpoint. So thank you.